Bismillahirrahmanirrahim. Today we will discuss another topic from the analytical chemistry from the spectroscopy, and that is called NMR. That is called NMR Spectroscopy. N means nuclear magnetic resonance. Nuclear magnetic resonance. NMR is the abbreviation of nuclear magnetic resonance. In 1925, A.H. Compton, one of the scientists, A.H. Compton suggested, A.H. Compton said that an electron can possess intrinsic angular momentum. That electron can possess an intrinsic angular momentum. That the electron can possess an intrinsic angular momentum. Angular momentum or spin. Angular momentum or spin. Momentum or spin. And thus behaves as tiny magnet. Please re-listen that A.H. Compton in 1921 suggested or said that an electron can possess intrinsic angular momentum or spin, and thus behaves as tiny magnet. After that, another scientist in 1925, Wolfgang and Pauli suggested that in the similar way the nuclei of certain atoms could also have a characteristic of spinning. Nuclei of certain atoms can also have a characteristic of spinning. It means they can circulate around their axis, rotating around their axis. Nuclei of certain atoms in the similar way also possess a characteristic of spinning or rotating around their axis. The spinning of these charged particles yani circulation of the charge generates a magnetic movement. Magnetic movements generates a magnetic movement. Circulation of the charge generates a magnetic movements along their axis of spin, or creates a nuclear dipole, so that these nuclei act like a tiny bar magnet. So these nuclei can act as tiny bar magnet. So these nuclei can act as tiny bar magnet. Along their axis of spin or creates a nuclear dipole. So these nuclei act like a tiny bar magnet. As a result, when these nuclei are exposed to, अब ये जो न्यूक्लियाई हैं जो ये शो करते हैं, अगर हम उन पे एक एक्सटर्नल मैग्नेटिक फील्ड अप्लाई करते हैं, C1 will apply an external magnetic field, their energies are split into two or more quantized levels. The reason is that according to quantum mechanism, the spinning of charged particles must align itself either with the external magnetic field, either with the external magnetic field, that means it is more stable and have a low energy, more stable and have a low energy, more stable and low energy, yani ground state. And second, against the external magnetic field, align with the magnetic field. Second, align against the applied magnetic field, that is less stable and have a higher energy level. Yani higher energy level mean excited state. In the first state, when they are aligned with the external magnetic field, they are in the ground state and have lower energy. In the second state, they are excited. They are excited and have a higher energy. Transition among the different energy levels. Transition among different energy levels can only be made if electromagnetic radiation, if electromagnetic radiations, of the current frequency, if the electromagnetic radiation of the current frequency is absorbed and the tiny bar magnet is flipped, to the less stable excited state alignment against the field. The nuclei are composed of protons and neutrons. The nuclei are composed of protons and neutrons and has a unit positive charge, while the neutron is electrically neutral. There are three types of atomic nuclei which show the magnetic properties. First category include those nuclei which have odd atomic number and odd mass number. Odd atomic number and odd mass number. The nuclei first. Odd atomic number and odd mass number. Mass number, these are hydrogen, nitrogen, fluorine. Hydrogen, nitrogen, fluorine, 19 and 9. Second category include odd atomic number and even mass number. This is the atomic number which we have written here, and that is the mass number. Second category include odd atomic number and even mass number. And these include hydrogen and nitrogen. 14. Here, sorry, 2 and 1. Odd atomic number and even mass number. And the third category, they have even atomic number and odd mass number. That is carbon 12 and 6, even mass number, even atomic number. Oxygen 16 and 8. And the third one is sulfur 32 and 16. So that is all about the NMR, and that we have discussed here. That is the principle of NMR, nuclear magnetic resonance. If you have any question in your mind, please ask in the comments. and that is my book which I have written, textbook of analytical chemistry. Please, you can study from all these things from this book. Okay, thank you very much for your cooperation and coordination. Please like and subscribe the channel.